All right, welcome everyone. We can just get started as people are still signing on. So for just a reminder that we're doing a hackathon tomorrow night. It's not like a hackathon, like you have to like build something in like a short window and compete. It's pretty much just like an extended version of office hours where the staff will be available to help you with your projects, or if you're stuck on any concepts, or if you're running into bugs. So we'll be using it, we'll be hosting it on Gather. It's the same platform that you had Milestone 1 on. So it's weblab.2/gather. So that'll be tomorrow, and we'll keep on reminding you. But yeah, feel free to come join us. So today we're gonna have there's no workshops for today, but just kind of a couple lectures on different topics on web development. So the first one we're kind of gonna cover today is on promises and this new syntax called async await. And so we've kind of already talked about promises, and if they're still confusing, that's totally okay. We'll kind of review what they are. And then we'll introduce the async await syntax as well near the end. So first, just kind of define a couple of terms. So synchronous, right? We've all heard of this term synchronous, and probably we'll talk about the next one right after it. But synchronous here is, in the context, is just something that happens consecutively, like one after the other. We know exactly when it'll start, and we know exactly when it will end. So we call that synchronous. And usually we have like multiple operations that run synchronously. So one will happen after the other, and they will run as expected, right? But there's this other term that you've been hearing that's also asynchronous, right? And at a high level, it just means it'll happen at some other point in time. But really, it's just saying that we don't know when exactly it will start and when exactly it will finish, or one of the other, or both. We might know when we might start an asynchronous task, like let's say we want to run some operation. But if we don't know when it will finish, like at what point in time, and in this case, we're thinking about like milliseconds, like actual time, right? Then we call that asynchronous, because we don't really know how to do it, right? And one thing that we want to do in our website is make sure that we can handle these two types of operations. So just a quick analogy, right? Probably earlier this semester, and maybe now when you're starting to think about classes, right? You're all asking yourselves, is this class synchronous or asynchronous? Is this class going to be happening and I need to be there when it's being offered? Is synchronous, right? Or is it one of those classes where it's just recorded and I can watch it on my own time, right? And it's asynchronous, right? Because me as a student, I'll watch it at my own time, and it's not guaranteed when I'll start the lecture recording and when I'll end it. It could be the same day that the lecture is offered, or it could be the night before the final. But regardless, we call that asynchronous because we don't really know when it will start and when it will end. So that's just kind of like a quick motivation, right? So why are our websites asynchronous? This might be an interesting question, but does anyone have any idea on why our websites might be asynchronous? Or maybe if you have an example of something that's in our website that is asynchronous. You don't know when people use them, gets taken a while. Yeah, so someone said gets take time. Yeah, so that's one reason. Yeah, it can be a little bit more efficient. Sometimes we'll kind of talk about like what happens when you have how to make asynchronous functions efficient, because you don't want to just be like stalling on your website, that you want to make sure that they're dynamic, right? But yeah, so kind of the primary motivation is that they're asynchronous because we're making a bunch of calls to different machines. And someone alluded to like a GET request, right? So let's just review what's going on in our website. So we have a client, which is like your laptop, your own version of your website, whether it's your deployed site or your local host 5000. And then we've also introduced this new concept of a server. And we were talking about this last week, and this week we're building APIs, and we're also setting up authentication and sockets, right? That exists in the server. So the server is a different machine that the client communicates with, right? And then we also introduced a database, right? Which is, it's actually a different machine that exists. And and basically our website is communicating with all these machines. And there's kind of a flow that goes to it, right? So let's look at the example of the GET request, right? So let's say your client is gonna talk to the server, and it's gonna run a GET request. It's gonna say, hey, can you get the comments? Hey, API, get all the comments. So the server is going to get that and be like, okay, Well, I know that my comments are stored on the database. So then it's going to communicate to the database, which is a separate machine, to get the comments. And so we can use this nice syntax that's comment.find, and that will basically get all of the comments that we have. And then when the database gets that incoming request, it'll be like, okay, sure, I'll give you a list of all my comments. And that gets passed back to the server. And then the server will be like, okay, cool, I got the comments from the database and the client was requesting it, so I'm going to send it back to the client. And we do res.send comments is probably what you've seen. Right, and so this is a pretty standard flow, right? But what's happening is that we're communicating to different machines, right? And this is just for one request. This is just one request. It's the API comments request. And whenever we communicate to different machines, that's kind of where we start getting asynchronous functions, because we don't know how long it will take. We can't guarantee how long it will take to communicate to a different machine. So these arrows and boxes is kind of what brings this asynchronous part to our website. It's that, if your client is going to run this function, the server could be down, your database could be wrong, there could be an error somewhere along the way, right? It's not guaranteed because we're communicating to a different machine. And we're just hoping that that machine is working and it's going to return what we expect it to return. So that's why they're a little bit asynchronous. But it turns out that JavaScript has this really cool, basically language system that we can use, and it's promises. So you've all heard of promises, and if you're still a little bit confused, like what exactly is a promise? That's totally fine. A promise is really just like this placeholder value for something that's unknown when it's first created. And so anytime we can associate like a function to a promise for any asynchronous action, like if we do a get or a post request, or if we do a Mongo database read or a write call, that's like accessing data from our database or writing data to our database, right? All of these actions are asynchronous, right? And promises allow us to attach a function to that asynchronous function that basically says like, hey, once this action is done, run this function. And that's basically what we're doing here with promises. So a little bit more about promises is that they exist in 3 states. There is a pending state, which is really like the initial state. So it's neither fulfilled or rejected. We'll kind of talk about what that means, but it's really like when you first declare a promise, it's kind of just pending. It's like this unknown state. It's like, I'm just this placeholder. I promise I'll let you know what I actually represent, but for now I'm just pending. I'm this placeholder value. And then the promise can go into one of 2 states. It can either resolve, meaning that the operation was successful. That's like comment.find and it gives us comments back. And or it could be rejected, meaning something happened. There was an error, right? It couldn't connect to our database, or there is a syntax error, or there were no comments didn't exist or something, or there's just some error that we encountered. And so promises allow us to basically handle those errors. So you've probably seen us use .then. So .then allows us to handle any resolved promises. So anything that after it completes, we can put a function inside .then, and inside .then is what's that function that's inside is going to run whenever we resolve the promise. But it'll run. But if there's ever an error, it'll basically catch it with the .catch, and it'll run the function that's inside the .catch. So we're basically attaching 2 functions to our promise. A function that tells it what to do when it succeeds, when it's resolved, and a promise on what to do when it's rejected. And the reason why we have to use, or why we attach them is because they're asynchronous, right? We don't really know when it will be done in time. So we just say, hey, promise, whenever you're done, if you succeed, if you're all good, run this function. If you run into any error, run that function. And then you just declare it like that. So that's kind of like a quick overview on the 3 states. We'll still be talking about these throughout this lecture, but let's just move on to talking about the first state, the pending state, right? So whenever you declare a promise, so we've already seen these promises, like a get, and you give it a route to your API, and then you pass in parameters, right? So for purposes, this is like not what you should do, but I'm just kind of going to show you what happens when you run this code. So let's say we run this function like as if it's any other function, right? Let's say we don't even know that get is asynchronous. Let's say it's just like some function that we expect to run when we pass it an input, pretty much just like any other function. And it's going to return something. And so we assign it to this variable comments, and then we want to print out the comments. And what's going to happen is that in your console.log, it's actually going to say that your promise is pending, right? So this is what happens when we don't really attach any handlers to catch any asynchronous calls. So this is kind of like what the initial state looks like. But remember, we introduced .then and .catch, right, to handle the different states of the promise. And so what we do is right here. So this is probably what you've seen more and what you're a little bit more familiar with. So .then will take in this callback function, and so we pass in some parameter called comments. What we call this variable is pretty arbitrary. It doesn't really matter, but it should be something that actually is representative of what your result is. And this output is linked, or this variable here is linked to the output of whatever our asynchronous function is. So if asynchronous functions are just like regular functions, they can still return something, but they need to, we don't know when they'll return it. So that's why we use .then. And .then will basically take the output of our asynchronous function, and we can do something with it. In this case, we're updating the state of a component, but it can also catch an error. And so in this case, we're just reporting the message from the error. So usually it'll go to one of two states. It can actually go to then and .catch if it encounters an error in the code that's in the .then, because this will catch any error. It can catch an error from your initial asynchronous function, or it can catch an error from any code that's inside the .then block. So what we see is that this .then block represents like the resolved state of the promise, and it'll basically handle, it's basically the function that will run when the promise succeeds. And then the other part that's down here is .catch. So this is how we're kind of representing the three states. So the initial state, and then the resolved state, or like the success state, and then this is the error state. So in this case, we're using .catch, and it's similar to .then. It takes in a parameter, what we'll call it error, and we pass it into this function that'll just print out the error. So that's kind of like a brief overview of like what a promise can do. You can do a lot more with promises. So one thing that you can do is Promise.all. So let's say you have, this is like kind of like a fun syntax. You don't have to like use this in your website, but it's just something to be aware of. Let's say you have a bunch of asynchronous functions, and you basically want to get all the data from each one. Like let's say we want to get the comments for 5 different posts, and so we pass in 5 different parent IDs, right? Because it's asynchronous, we don't want to wait for each one to finish and then move on to the next one, run an asynchronous, wait for it to finish, and then update the state, and then go to the third one and wait for it to finish, then get the result and update the state, and so on, right? And so what we can do is we can actually create an array of pending promises. Remember that when we don't attach any .then or .get, and we just attach like, we assign it to a variable, this is a pending promise, right? So we can create an array of pending promises, right? It's basically like all of these promises need to run eventually, and we're just putting them together in a data structure in our list. And now we have this list of promises that basically represents a bunch of functions that need to run asynchronously. And so one thing that we can do is introduce this syntax called Promise.all. So the way we do it is we do promise with capital P, .all, and then we pass in an input, and the input always has to be an array of promises. And usually they should be pending promises, because what this does is that it'll basically run them all at the same time, and it won't execute .then until all of the promises in the array have finished. And let's say if only one runs an error, then it's basically gonna throw the error for the entire promise. It won't give you like partially resolved results. And we'll talk about other ways that you can handle partially resolved results. But whenever when you're using Promise.all, it'll only execute .then if all the promises in your array succeeded. So basically what it's doing is it's going to go through the list, and it's going to say, all right, I'm going to run each one independently. And then if I finish them, then I'm going to pass it into the results. And then if all of them finish, then it'll execute. But if any one of them, like let's say like the fourth one randomly fails, right? For whatever reason, a network connection, the server error, a database issue, whatever it is, right? The fourth one randomly errors, but all the other ones are successful, it's still gonna throw an error. Does it run? Yeah, so this is the thing about promises. It schedules them, and there's a whole nother topic on how it does that that we won't cover now. It's called the JS event loop if you're interested in it. But because it's asynchronous, we can't guarantee when it will start and when it will end. So Promise.all is just saying, run all of them, and then once they're all done, like let's say the first one is like instantaneous, but the last one is like taking a while, right? When they're all done, it will work, right? And so that's what dot then will do. But then there is another way that we can handle this. So promise.race is basically saying when the first one is finished, just move on with that one. We don't even care about all the other ones. It's kind of like they're all racing together, and the first one to cross the finish line is the result that we're going to get. So we use promise.race, and we pass in that array of promises. And here we've actually renamed it. Remember that the variable here can be whatever we name it, but it should be something that's like indicative of what we're doing. So we called it first result because it's going to do something with like the first result we get. So that's promise.race. And then the last one is promise.any. And this is like, let's say 4 of them fail, but 1 of them succeeds, it will still take any result. And so this is pretty much like the opposite of Promise.all, where all of them have to fail, or all of them have to succeed in order for it to go into the dot then. In this case, it only needs 1, right? Any result, right? Regardless if all the others fail, let's say you have a list of 100 promises, right? I don't know how for performance-wise that would work or how well that is, but let's say 99 of them fail, but 1 of them succeeds. If we use promise.any, we'll still execute dot then because it just needs any singular result. And yeah, can you tell a promise to rerun until it doesn't fail? You might have to, promise.all doesn't handle, promise.all will just execute once, but you can wrap it in a function and do some other methodology that will basically check if there's an error check, like rerun the function that's wrapping it. But yeah. So that's promise. You'll probably be using, of all the 3, promise.all, promise.race, and promise.any, you'll probably be using promise.all like the most, but again, you're not required to. It's just another tool that if you want to use. That's kind of on promises, right? But right now we've just been looking at promises like where the client is communicating to the server, or is communicating to the server, and then the server is going to send a response. We're getting comments, and then the server will respond the data from our database, right? But it turns out that your server code can also have promises, and it already does. And you may have not seen this because it doesn't look like a get or a post request, right? The get and the post request is kind of the methodology and the functions that we use to communicate from the client to the server. But remember, from our structure, we also communicate from our server to our database. And we're doing that with Mongoose. If you remember from the MongoDB lecture, Mongoose is the library that allows our server to communicate with the database. And we have models and schemas that allow us to basically extract our data. We're not necessarily running like get slash like, Mongo, like the MongoDB URL slash your database and all that. The Mongoose library basically kind of allows us to just work with our models only. But so this is something that's really important. And so for the next couple of minutes, this is going to be like just some exercise that we're working with together. There's no code that you need to pull. You can just like pay attention, and I'll try to answer any questions. But we're going to do an example of like how a server communicates to a database and how we can use promises and how we can basically make it look nice. So first, let's just introduce this piece of code. And we're going to do it without promises at the beginning. And so what this is doing is that it's this function mongo client.connect. It takes in a URL, and then the second parameter is the callback function. Notice how it has the comma here. And then the second parameter is this callback function that will execute after it's connected, right? And because we're not doing promises, we actually pass in the argument error and database, where error represents if it failed, and database, DB is our database. And it's like if it succeeds, that's what we get. And what we want to do is that first we want to check for an error and report it. But if there's no error, then we want to go inside our database and go into the user collection. And so we're going to do .get collection and get the user collection. And again, very similar. Now we're passing in another callback function, but in this case, the parameter, the set, it still takes an error parameter, and now col stands for collection. And if that works, again, we're going to check if there's an error. And then if it doesn't, now we're going to go inside of our collection and see if we can find a user. This is our user collection. Find one user whose name matches Robert. And so that's how we do find one. And then we pass in the filter condition, so it has to match name and Robert. And then this is our callback function again, error and user, and we pass it into curly braces. And then again, we have to check if there's an error. And then, let's say it doesn't, right? Then we have this user, right? But our database can return null, like basically saying, I was able to finish going through the database. I didn't find anything that matched with Robert, but I was able to finish that operation, but I'm just going to return null. And so that's what null is. That's why we would get a null user. But let's say if the user is not null, then we want to do something with this user. So in this case, we're going to update this user. And so we do that by doing collection.update. So we don't do update on the user, we do it on the collection that has the user. And we pass in the ID of that user that we want to update. And then this right here is just the operation that we're doing. You don't need to worry about this for this lecture. This is just the Mongoose syntax to basically update a field of the user. So in this case, we're updating its age to 21. And after that executes, we have this callback function that will basically say, it takes an error result and we do something. If there's an error, we break. Otherwise, we can do something to indicate there's a successful update. But let's say the user does not exist, then we want to insert the user into our collection. So we're basically adding something to it. And again, when we insert it, we have to basically tell it what to insert. So we're like what this new user looks like. So the user has a name and an age. And then after it's been inserted, we have another callback function, error, and it takes in an error and a result. And again, we have to do an error check. And if it is, we break. If there is an error, we would break. Otherwise, we do something successful with an insert, right? So this is like pretty much like an operation to just, update someone's age or update a user age. And if the user doesn't exist, insert the user with their new age, right? But one thing that's happening is that there's a lot of like function handling and just things that like don't really make the code nice and everything. And so one thing that we were talking about was that your server code, this would be like inside your router or something like that. Your server code has promises. And so all of these functions that are boxed in red are actually asynchronous functions, because this is us on the server calling a function that communicates to our database. We're connecting to our database. We're getting a collection from our database. We're finding something in our database. We're updating it, right? We're inserting it, right? And so these functions are asynchronous, right? And so that's why we pass in these callback functions, because it says, after this has happened, execute this callback function that takes in an error and a column. And so the way that we can fix this, right? It's very much nested. It's not the cleanest code, right? What we're actually going to do is we're going to create, we want to basically improve this, right? And so we want to improve it. Can we do better? Short answer of this lecture is that yes, we can do better. And so we can create a chain of returned pending promises. So what does that mean? It basically means that we're going to return promises that are still in their pending state, and we're not really going to resolve them yet. And we're going to create a chain of them. So, and we'll kind of explain what that looks like. And when you see the code, you'll understand how it's a chain. But first, I'll just kind of show you how we do that. So first, we'll start in the inside, more inner code. So column.update and column.insert, right? These are asynchronous functions that have handlers, right? But we're going to just return the pending promise. So we're basically going to cut it off after we set the age. And so the way that we do that is that we just shorten the code. So this is what it looked like before. We updated it, or we would insert with the parameter, and then we would add a callback function. But now we're getting rid of the callback function, so we're just returning the promise in its pending state, right? And that's like starting at the middle, right? But then if you look at this like next block, right, column.find one, it will execute some function in the middle, it'll execute this callback function. But after that, like once it gets to line 15, what's it going to do, right? It doesn't really do anything, right? So we want to return the output of column.find one. And we can return the output because the output's actually defined in this nested function. So we just do return. And then we're going to continue to expand that to get collection. db.get collection, it's running something, but it's not returning anything, right? We just say, hey, database, get the collection, and then that's it. And then it'll do its own asynchronous calls. It'll run this callback function, right? But that's it. And so we want to return it. And so the reason why we return it is because at the end, this is a function that we want to send something back to the client. And then we can continue to, remember, connect is also a, oh wait, hold on, we'll get to that. So this is what we're actually at right now, right? But the next thing that we've noticed is that, that we have errors and columns a lot, right? And we introduced that syntax then and .catch to handle the different states of the promise. And so we are actually going to transform, this code to use .then and .catch. So I think I went a little ahead, but this is basically the next step is we're using .then and .catch. And so here we can actually start by looking at this function on line 8. This is basically the callback function that will run after column.find1. But instead, rather than doing like error user, right, we're just going to convert it to use .then and .catch. So it'll look something like this. So after column.find1, we're going to do .then, and it'll give us a user, and we run this function. And if there's an error, we'll report the error. And we can continue to expand this pattern to user collection .then. And when we do this, notice that we do .then, but we also had to do another catch because this catch is for every then will need a catch. So we have 2 thens and we have 2 catches. So it's kind of like the .catch for the outer function. And then connect is also another function up here that's asynchronous that uses this callback function. So we're also going to introduce .then and .catch for this one. And so now we see, okay, where this is looking a little bit better, a better way to handle code, right? We're using .then and .catches, right? But remember that our goal is to create this chain. And just for purposes of time, I'm just going to go through this a little bit. So one thing that we don't like is that we have these .catches, right? So what we're going to do is we have 3 .thens and 3 .catches, is that we want to consolidate the .catches into just one catch, right? It'll be easier because it can catch any error. And so the way that we do this is that we're actually going to, this .then and .catch is we're just going to pass in this chain. And this is how we build this chain. So here we're going to do .then. It's going to be a little bit weird, but notice how we're basically plucking out the .then. So I'll show you before it's .then, but now we added this bracket here that is basically saying just return this promise here that has been pending, right? And we're going to continue to do that for here right now. So .collection and same thing. And so now we're seeing that we can start having this chain that's just getting passed to the next level. And this is a little bit nicer, right? Database, collection, and user. And eventually we just have one .catch at the end. So this is like a little bit of a nicer way to do it. I know I still have to get to one more thing, so I'm just going to speed through this a little bit. But so basically when we do this chain of promises, we only have one level of nesting. We can do error handling with just one catch, and it's just one continuous branch. So it's going to run sequentially. So it's going to get the database collection, and then it's going to pass it to the next .then, and we're going to pass in the collection and try to find a user. And if we find a user, it's going to pass it .then. And so this is basically the chain that we created of pending promises. So if this is a little bit fast, don't worry about it. This is just kind of like, there's even a nicer way to write this. So the last thing we're going to cover is async await, which is this new syntax in JavaScript that basically makes your code look synchronous, but it runs asynchronously. And it's a little bit nicer and one of my favorite ways to write this code. So we basically await on anything that returns a promise, like that pending promise. The code looks synchronous, but it will execute asynchronously. And it actually makes the code look a little bit nicer. So let's start by just plucking out all of the asynchronous functions as if they were their own line, right? So we do mongo.connect, db.get collection, collection.find1, and then the update and user, right? And so we pluck it into this, right? And so now it looks like this is like, oh, it's asynchronous. We do some operation, return it, assign it to a variable, move on to the next line, do some operation with that variable that we just created and assign it to a new variable and things like that, right? Async await, allows us to introduce this await keyword at the front. And basically it's saying, hey, don't execute the next line of code, like line 2, until the first one has been resolved, right? And it's only saying if it's been resolved. Like it's not gonna, if there's an error, it's not gonna assign DB to this error value. It'll only assign it if it's successful, if it's been resolved. But in order for these wait keywords to work, we actually have to attach it inside a try catch. And the try catch will basically say if there's ever any error when it's trying to connect or when it's trying to get a collection or find an error, we will catch the error. So it'll kind of basically break this function and go to the catch block. That's basically what the syntax is doing. So remember that whenever we do a wait, it's not going to assign the variable to the error value. It's only going to assign it if it's successful. That's why we need to have this catch, this try catch. It always has to be in a try catch because the catch will basically catch any error. It's not going to assign DB to some error value and then we do error.getCollection. That won't work. So we use .catch. And then the last thing that you need to know is that whenever you do, whenever you use await syntax, you always have, this is where you'll probably encounter the most bugs, is that you always have to wrap it inside an asynchronous function. And the way you do that is that you write this word async before the parameters to any function. So this is an example of putting it in our API. Let's say we're trying to post a user and the callback function is now async. So now we've declared that this function that we pass in is going to run asynchronously. And when we say it's async, then we can use this nice await syntax. And this looks a lot more cleaner. I know I've gone a little bit over, so you have a little bit more questions. Feel free to ask in the questions doc. But just remember that, yeah, here's the async await, that if you ever use this async await syntax, it always needs to be wrapped inside an async function, and it reads synchronously, but it actually runs asynchronously, and it has to be wrapped in try catch. So that's kind of the last part of async await. If there's more questions about it, I know we kind of sped through it. It's really just a beautiful syntax that lets you write synchronous code asynchronously. But if you have more questions, feel free to put them on the question down. But yeah, I think Kai is next. Are you next, Kai?
Yep.
All right, awesome. Yeah, thanks everyone.